Hello everybody, this is Digital Blackboard by Sachin P. Nagmatan. In this video, we are going to solve one problem of parallel RLC circuit. So the problem is given as two impedances, Z1 is equal to 6 plus J8 and Z2 is equal to 8 minus J6 are connected in parallel across 100 volt supply, and determine current and power factor of each branch, overall current and power factor, and power consumed in each branch and total power. So these two impedances Z1 and Z2 are connected in parallel. So 6 plus J8 and 8 minus J6. So as in Z1 there is 6 plus J8. So the sign of this imaginary part is positive, and that's why this J8 is representing inductive reactance. Whereas in Z2 we are having 8 minus J6. So sign of this imaginary part is negative. So that's why it is representing capacitive reactance, and that's why in first branch we are having resistor and inductor in series, and in second branch we are having resistor and capacitor in series, and these two branches are connected in parallel across 100 volt supply. Okay, now we have to find out current and power factor of each branch. So let total current is I, so this I current will get divided in these two parallel branches. So let it be I1. So this is I1 flowing in the branch Z1, and this is I2 which is flowing in the branch of Z2. So we have to find out in the first part, we have to find out current and power factor of each branch. It means we have to find out I1 and I2 at this, and power factor of this first and second branch. In the second part, we have to find out overall current and power factor. Means in the second part, we have to calculate the total current, that is I, and power factor of the whole circuit. And in the third case, we have to find out power consumed in each branch and total power. It means power consumed in first branch, power consumed in second branch, and the total power. So let us start to solve this problem. So first of all, we will find out the current of first branch, that is I1. Now for first branch, it is already given R is equal to 6 ohm and XL is equal to 8 ohm, or simply Z1 is given 6 plus J8 ohm. So we can use the Ohm's law here. So according to Ohm's law, I1 is equal to V by Z1. I is equal to V by Z. But as we are finding out the current for first branch, so first branch current is I1, so it will be V by Z1. The voltage, this 100 volt voltage will remain same for both the branches because this is connected in parallel. So let us put the values. So we are having V is equal to 100 and Z1 is equal to 6 plus J8. So now we can perform this complex calculation. Now how to perform this complex calculations, it is also explained in my previous video. So I'm sharing a link of that video in the description box. So we are getting 100 upon 6 plus J8 in the polar form as 10 at an angle of minus 53.13. So we are getting this I1. So 10 is the magnitude and this minus 53.13 is the angle of this current making with the voltage. So we got the current of first branch. So similarly, we can find out the power factor. So power factor is given by cos phi, and phi is already there, that is 53.13. So let us take cosine of this 53.13. So we can have the power factor, that is 0.60. And as the sign of this angle is negative, it means the current is lagging, and as the current is lagging, the power factor is also lagging. So we got the current and power factor for first branch. So in the same way, we can find out the current and power factor of second branch. So for second branch, the Z2 is given as 8 minus J6. So I2 will be equal to V by Z2. So let us put the values. So 100 upon Z2, that is 8 minus J6. So it is coming I2 is equal to 10 at an angle of 36.86. So we got magnitude and angle phi. Similarly, we can find out the power factor, that is cos of phi. So phi is already there, that is 36.86. So let us take cosine of it. So we can get cos 36.86 is equal to 0.80. And we know that the angle of this, as the sign of this angle is positive, it means current is leading, and as the current is leading, power factor is also leading. So we got the current and power factor for second branch. Now we have to find out the overall current and power factor. It means total current. So total current will be I1 plus I2. So let us add I1 and I2. So total current I will be equal to 10 at an angle of 53 minus 53.13 plus 10 at an angle of 36.86. So it will come in the polar form 14.14 at an angle of minus 8.13. So we got overall current, and for overall power factor we can have the cosine of 8.13. So cots of 8.13 will be 0.98. And as the sign for this angle is minus, so current is lagging. It means the power factor is also lagging. So as we got here, we got the overall current and power factor. Now we have to find out the power consumed in each branch and total power. So for the first branch, the power formula for power is P is equal to I1 square into R1. So remember, whenever there is a resistor, inductor or capacitor, the power get consumed only in the resistor. So for the first branch, the power will get consumed in only the resistance of this 6 ohm, and in the second branch, the power will get consumed in the resistor of this 8 ohm. So for first branch, the P1 will be equal to I1 square into R1. Now we have to take only the magnitude of current. So in the I1, while we calculated I1, we are having magnitude as well as angle. But here we have to take only the magnitude part of it. So P1 will be equal to 10 square into 6, because in the first branch the resistance is 6. So it will be 600 watts. Similarly for the second branch, we will be having the formula P2 is equal to I2 square into R2. So 10 square into 8, because the resistance of 8 ohm is connected in second branch. So it is 800 watts. And total power will be the summation of this P1 and P2. So we are getting 600 plus 800, that is 1400 watts. So we got the power consumed in each branch and the total power. So in this way, we solved this problem of parallel RLC circuits, and we got the current and power factor of each branch, overall current and power factor, and power consumed in each branch and total power. So I hope you understood this problem very well. Thank you very much.